The SAT and ACT ask us a surprising number of questions that involve basic understanding of how to operate with fractions. And so today's video is going to focus on the basic rules we have to follow when we add and subtract, multiply and divide fractions, and carrying those rules over even when we are given variables or unknowns. So the first rule we have is when adding and subtracting fractions, we have to have a common denominator. And a common denominator can also be known as like a common multiple. So when we look at this first example here, we see that our denominators are 4 and 3. Now the fastest way to find a common denominator is just to multiply them together. So we can say our common denominator here is 12. Right? Now the important thing to do is when we change our common denominator, we're not just randomly changing the number. What we're doing is we're multiplying the bottom, the denominator, by a value, and that value needs to be multiplied to the top as well. So 3/4 converts into 9/12, and with 5/3, the values I'm going to multiply by are 4. So 5/3 converts into 20/12. Adding these two together, I get 29/12 as my sum of these two fractions. Now, if I'm going to take that concept and apply it to variables, I just need to do the same thing. I need to multiply my two denominators together to get a common denominator, which will be BD. And then I need to multiply the numerators by whatever I multiply the denominator by. So this first fraction, AB, I'm going to multiply the top and bottom by D. So I get AD. And the second one, I'll multiply by B over B. And it's going to be a little bit hard to see, but I'll write it right here. So it'll be CB over BD. And I copied the problem down wrong. This is actually a subtraction problem. But here we see we have two common denominators, B and BD, and we have two new numerators based off of how we converted the denominators. So the combined fraction, and bear with me here, this looks kind of crazy, will be AD minus CB all over BD. Okay. This exact problem probably won't show up on the SAT, but I just wanted to show you guys how you could take a pretty familiar concept, right? Something that most students learn either in high school or middle school, and apply it to variables, right? And that's what the SAT loves to do. Like I mentioned, the SAT loves to take basic concepts and throw in variables or throw in unknowns and see if they can trip us up. Okay. The next thing is when dividing fractions, you want to multiply by the reciprocal. This is sometimes also known as keep, change, flip. So what we're going to do is we're always going to keep the first term the same. So I'm just going to rewrite that. Our first fraction the same. But then we're going to change the division to multiplication. So I'm just going to use the dot sign for multiplication. And then we're going to flip our second fraction. So we call that a reciprocal. So AC becomes C over A. And now that we're just multiplying, we're just going to multiply straight across. Some of you may have noticed that there's actually a cancellation I can make. I can cancel these two A's out. So my final answer ends up being C divided by B. We kind of already showed this in the previous problem, but the next concept I want to go over is cross-elimination. Right? We can cross-eliminate fractions if there's no addition or subtraction between the fractions. That's important to note here because we see addition going on and subtraction going on within the fraction. But the rule here is as long as there is either a multiplication or division sign between the fractions, then you can cross-eliminate. So we cross-eliminated in the previous problem right here with A and A because we were multiplying. Here we're going to cross-eliminate the 5x plus 2 and the 5x plus 2. Now some of you might be thinking, what about this 3x plus 4, 3x minus 4? Is there any way to mess with that? And although they look very, very similar, there's nothing we can do with that. So we're just going to eliminate these. And be sure to remember that when we're eliminating, it's not a 0 that's left. It's actually a 1. Right? We're not completely eliminating, meaning like getting rid of all the values. We're actually just simplifying it to 1 over 1. So multiplying this across, I get 3x plus 4 over 3x minus 4. Okay. And the last example here, we're probably going to need a little bit extra space, but when two fractions are equal to each other. So this is different than the previous example where we're using multiplication or division. Now when we say two fractions are equal to each other, what we can do is cross multiply. So here I'm going to multiply 5 times 5x plus 2 and 17 times 3x minus 4. And when you do that, you set those two expressions or those two equations equal to one another. So this is cross multiplication. And again, you can only do it when two fractions are equal to one another. You should almost always do it when two fractions are equal to one another. You cross multiply and you set them equal to each other. Now you need to remember to distribute. Right, so this will give me 25x plus 10 equals 51x minus 68. Okay, that was again distributing my 17 right here. So simplifying this, I'm going to bring the 25, I'm going to subtract 25 over on both sides, 25x. And I'm going to just need to move this over to the right side here to give myself a little bit more room. So I'll get 10 equals, because I subtracted the 25x's, they canceled out, equals 26x minus 68. And then I'll add 68 to both sides. That'll give me 78 equals 26x. Divide both sides by 26. And that'll give me x equals 3. Now this would be an example of what we could see expect to see on the SAT or ACT. Relatively medium to hard level problem, algebra problem that involves cross multiplication, involves a little bit of some difficult arithmetic, some difficult calculations. You may be asked to do this without a calculator. You definitely can. You just need to take your time, work through it slowly. You definitely do not need to do the problem, all the math in your head. But just follow the basic rules, right, with algebra and with fractions, in this case being cross multiplication.